brought to you by MuleSoft. Visit MuleSoft.com to find out how MuleSoft's API-led approach to connecting apps, data, and the Internet of Things can revolutionize your businesses.
Hi, I'm David Berlin, Editor-in-Chief of ProgrammableWeb.com, here with a special edition of the Developers Rock podcast. Now, every month in Washington, D.C., there is a special meetup that takes place on the first Tuesday of the month. It is the DC Area API Meetup, and this is where many of the technologists from across the federal government get together to talk about what works and what doesn't work in the way of providing APIs from government agencies, not only for internal consumption by developers, but for external consumption as well. Now, if you're interested in attending that meetup, I suggest you go to meetup.com and search for it by searching DC API User Group. And if you go to that webpage, you'll find not only the upcoming meetup and who will be speaking at it, but you may even find a schedule and other users who are attending the meetup. If you want to find out more about the meetup, you can go there. You can also go to the meetup's Twitter feed at DC_API_meetup as the Twitter handle. So I hope to see you there at the meetup. Meanwhile, what we decided to do is we're going to record all of the different presentations and publish them not only to Programmable Web, but also to Programmable Web's YouTube channel at www.youtube.com/ProgrammableWeb. These presentations will not only include what the speaker is saying, but you'll be able to see their slides as well. And if you go to the version that's on ProgrammableWeb.com, we'll include a full transcript of everything the presenter said. So I encourage you to check those out. So for now, I'm going to let you go and watch this next presentation that was filmed at the DC API User Group Meetup. Thanks very much, and I'll see you soon.
Show you in 10 minutes how you can put together a scalable API on AWS without having to touch the AWS console even one time. We might touch it a couple of times just to make sure that everything is going well, but you don't have to. And you should follow along, or at least take a picture of this screen so that you have access to this Medium post that we put up just so that you can then copy and paste a bunch of blocks of the code so that you can go and then use it yourself for your own programs. So a couple of weeks ago, my team and I decided that it's about time to put together a button to allow our users to flag whenever they see data that looks wrong or that looks inaccurate. Now, the data that we're dealing with is extremely important for our users because our users are Democratic candidates spanning the ballot from school board all the way up to the presidency. And they're using the data that we're sharing with them to make decisions about the way that they strategize for their fundraising efforts. And so whenever the data that they see is wrong or potentially wrong or suspicious, it's important that they flag it for us and file some report so that it can then go back into our system and improve the way we're building things. So this was the sketch that I put together. And it's a very rough draft, something unusual with the data. People are supposed to click it, and then they flag whatever it is that looks wrong, and it needs to go into our system. So I went up to my co-founder on Slack and I said, hey, Dustin, here's a take on the data accuracy button. And this is the visual of it. And this is the architecture. I said, when they submit a response, it'd be great to have it write the response, including the campaign ID, to S3. And if we share a bucket, or if you give me permissions to a bucket, say, that he creates, I'll just hook it up to the rest of our flow myself. So this is what the flow looks like. We got a user submitting some report. This is the app backend. And that app backend, in my mind, is then writing that message or that payload into S3. And then I have another instance. This is on the data engineering side that is pulling in that request. We're seeing the report, and we're sending it to an engineer. Now, the engineer that is working on this person, her name is Emily, and Emily's right here. Emily, you can say hello. She's right there. OK. So this is the infrastructure that I had in mind. And it isn't a good infrastructure. And very quickly, Dustin let me know that. And he said, can't you just create, he says can, but in my mind it's, can't you just create an endpoint that I can post the data to? That's much cleaner than sharing an S3 bucket infrastructure-wise. So what he had in mind is something that is much cleaner, which is basically this. This is the app backend. It's making some request, some like post request to this API gateway that is then triggering an AWS Lambda function that is writing it to S3, and they can send it then to Emily. So I put that, I sort of thought about that. I was like, this is very clearly the right way to go. I said, good idea. Here is an endpoint. And it took me about 10 minutes to put this together. And the reason it took me 10 minutes is not because I'm an excellent programmer, but because we're using very good tools to do it. So I want to share with you those tools, and I want to actually replicate those exact steps that I had taken for us to put together this entire workflow, where you're just exposing an endpoint, and anybody can post data to it, and that data then goes and is written directly into an S3 bucket. So before I do that, I want to see just by a quick show of hands, how many people here are using AWS? Of those people who are using AWS, keep your hands up. How many are using CloudFormation? And how many are using Terraform, which is a layer then on top of that? And how many people are using an even more abstracted layer like Pulumi to do it, where you can then script all of your resource deployment using your favorite language like Go, JavaScript, Python? OK, so it's that higher level abstraction that I'll be showing you how you can utilize. Just as background, you can go back to that Medium post and see a little bit more about that. Infrastructure as code is sort of industry standard at this point. The idea is that you shouldn't be going around AWS and clicking around while you're provisioning different resources and then gluing them together and then having to remember what it is that you did in the beginning and then replicating those exact same steps for every different stack, for your dev, for your staging, for your production. You shouldn't be doing all of that, which is all the stuff that I had been doing for a very long time. Instead, you should use some tool that is exposing access to all of these resources that you see on the cloud, but using Python or using JavaScript or using another language, and then construct an entire infrastructure on the cloud and tear it down just as quickly. And you could do that programmatically and dynamically, and there's many, many benefits for doing it this way. So sort of the overarching framework looks like this. We have something that's like a model.js, and I'm just defining this variable, EC2. This is a new EC2, and you're just calling it some name and feeding certain parameters to it. So this is what we'll be doing. We'll be creating an EC2 instance. Well, not in this case, but this is the idea of what you should be doing. In our case, this is the exercise. We have an API gateway, we have a Lambda function, and then we have an S3 bucket. This is what we'll be doing. We'll be building a certain resource, S3, and then building Lambda, and then building an API. So let's do that. You should click this link if you haven't yet, but so few of you have laptops, so that's not a concern. I'll be clicking this link, and this is what it is. And insofar as we have the time to do it, I actually want us to just run through this entire setup, and we'll do that together. So the first thing you got to do is download Pulumi. So Pulumi is that higher level abstraction. I had already done that, and you could see it. Pulumi version. Is this large enough? All right. OK. I have Pulumi. Next thing is Node. Do I have Node? I have Node. OK, cool. Otherwise, just brew install it or download Node, and I put the link to it. The second thing is to configure your AWS. If you don't already have an AWS account, you should create one. And then remember to turn it off, because otherwise you're going to be charged for all of this stuff. The easiest way to tell Pulumi where to find your AWS credentials is to just use the AWS CLI and to configure your own profile. So the way to do that is you install the AWS CLI, and then you go AWS configure, and it has all of your stuff there. So now Pulumi knows where to look for your AWS credentials. Cool, now let's create a Pulumi project. So we go Pulumi, new AWS JavaScript. So we're going to be using the Node.js version. And let's create a directory first. We'll call it API Hangout. Let's go there. Good. All right, so Now let's come up with a project name. Let's say API Hangout. That works. The description is fine. The stack is dev. Stack is just a collection of different resources that you put together that have a different configuration from one another. So for example, dev would be one stack, and staging would be another stack. Let's just start with dev for now, and we'll deploy it to US West 2. Now it's just going to download a bunch of stuff. But one of the things we can do is probably open this project and see if some of the stuff is already there. What did we call it? API Hangout. Yeah. All right. Let's see what we got. So I'm guessing and hoping that what it's doing while it's thinking is just downloading more and more of these node modules. And we still have access to play with some of these things. But can you see this, or is this too small? Let's see how to do that. View. Maybe enter presentation mode. Nope. What happened?
That's better.
Yeah. Okay. So now I need to see where everything is. Ah, here it is. You can see it better? Okay, cool. So we got a couple of files for free. The first one is just the YAML file for the Pulumi project. It defines just the name for all we have to worry about. The next thing is the pulumi.dev.yaml. This is basically where you write out all of your configuration. So this can be like your .env. So you keep all of your environmental variables here. We don't have to worry about that either. The main thing we're going to be dealing with is this IndexJS. This is what starts, this is what gets exposed to the Pulumi project. And as soon as you do Pulumi up, Pulumi UP, or up, it just reads this IndexJS, and this is sort of what gets exposed to the rest of the program. So one of the first things that it does is it just loads all of these different Pulumi libraries. And you can already see that it started out by giving us a free bucket. This is const bucket equals new aws.s3.bucket. And this is the name that Pulumi is reading. And so every resource gets its own name. This is not going to be the name of the bucket, but this is the name of the bucket resource in the Pulumi world. We can get a better sense for that, I think, here. Yeah, we have new, and then the resource, and then the name of the resource. And then one of those parameters is going to be maybe the bucket name. OK, let's see if we're ready. OK, we're ready. So now let's do Pulumi up. And it's going to show us what exactly will be deployed. OK, do you want to create these two things, which is the stack and the S3 bucket? Let's look at the details. Some of this might be familiar if you've been working with CloudFormation. Yeah, let's do it. So do you want to perform this update? Yes. And now what we should do is go to S3 and see that it's actually worked. All right. This is the bucket name. Let's see that we actually have it. Yes, it's right here. All right, nice. So we just managed to create an S3 bucket without having to touch the console. Let's march through this a little bit more quickly now. The next thing we want to do is change the name of this bucket from my bucket to something that's a little bit more explicit. So let's just destroy the stack. So we do Pulumi destroy. And now it's just going to remove that bucket, and we're going to rename it. And the way we're going to rename it is by making reference to the actual stack, so that the name of the bucket that we're going to see on S3 has some reference to the stack. So it's dev or prod or staging. Let's do that. Instead of this, we'll do this. And API Hangout. Let's say API Hangout bucket. All right. Let's run this. And we should see it having been created. Let's see. This is going to be the name, API Hangout bucket. Live demo. These are risky business.
Yes.
We're taking those risks. Let's see it. Let's refresh. OK, nice. Here it is. API Hangout bucket dev. Cool. Next thing we want to do is create the Lambda function. So this is the code for the Lambda function. It's just new aws.lambda.callback function. Feed in the name, and then we feed in the parameters. If you don't know what the parameters are, it's very easy. You just click on the documentations. It gives you all the different parameters that you can feed in. So let's do that. Lambda. OK, now notice that there's a couple of interesting fields here. One is role, and the other one is callback. So let's call this, let's say, API Hangout, Payloads API Meetup, Lambda. The name of this should be maybe API Hangout. And we need a role, and we need a Lambda function. So a role just allows Lambda to interact with different resources. We can create one with the exact same template, right? It's just new something something dot role, and then we name the role, and then we feed in the parameters. Let's do that. I just created one, new aws.iam.role, the name of the role, and then we assume a policy, and you see there's basically nothing happening in that policy. It's a very raw policy. OK, let's create role payloads. We'll call this API Hangout. This is going to be the role, and this is going to be the role that Lambda takes. And now Lambda also needs a function. What is that function that Lambda will be invoking? We can start with a very basic function, right? This function basically does nothing, right? So it's just an async function. There's an event parameter, an argument that is fed in, and it just returns a status code of 200 with a body of success. Let's add a little bit more flesh to it. Let's decode the actual body of the event. So you can see here that whenever we're going to be invoking this Lambda, the event.body is going to have the payload itself. And so we have to convert that to a string. I have to return it into a buffer. So now we have access to the payload. And we want to write that payload to S3, right? This is what the goal is, to take the payload into Lambda and to feed that into S3. This is the way you feed things into S3 using promises and await. And I'll also show you how we do ES6 so it doesn't yell at us. And we're almost done. OK, cool. So now we put the payload into S3. And we have to specify what the put params are, right? So we have to specify what the key is and which bucket we're feeding it into. And the key should be, this is just the name of the file. We could just pick the timestamp of when it was loaded. The body will be the payload. And the bucket, notice this is interesting. Now it's expecting an environmental variable that has the name of the bucket. We haven't fed that in anywhere yet. So this is one of the next things that we have to do. When we create this function, we have to make sure that we're also giving it we have to make sure that we're giving it the name of the bucket. So let's do that here. Callback. And the environment field. And the variable. And notice, this is cool. The variable that we're feeding in is S3 bucket. And that is just the bucket object that we created earlier, .id. So now we're building all these interdependencies into this function. So that's kind of cool. What else do we need to do? We don't have access. We are calling S3, but that is undefined yet. So let's just create an entry here. And we're just requiring the AWS SDK. OK. That should be it. So let's just run this and see what happens. Unexpected token, index 69. I knew something was up here. All right, let's try now. OK, so do we want to create this role and this function? Yes. OK, it's creating. And we should test it. Let's go to Lambda. And the name of this function is going to be API Hangout Lambda. Let's see if it was created successfully. OK, nice. 'It's. 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 All right, it's right here. Here we go. Boom, you can see it. And this is our code. So at least it deployed to Lambda nicely. The only problem now is that this Lambda is fairly isolated. We can't even trigger it with an HTTP request. And so you might remember this original image here. There's nothing that is interacting with this Lambda. So we need to put it behind an API gateway. So let's create the API gateway. And as you can probably guess already, it probably looks like new API.API gateway with the name of the API gateway and a bunch of parameters. This is it. Let API gateway equal this whole thing. And we're very close to finishing. Let's call this API Hangout, the API gateway. And now we need to pick a path. So let's just call it, posting to S3. The method is a post. This is the route. And the event handler, it will trigger this Lambda, the one we had just created. Nice. Spaloo me up. And as soon as this is done, we're going to notice something interesting about this Lambda. Load. You can see that now it can be triggered by an API gateway. So this is very nice. Now I actually have a URL that I can copy into, say, Postman, and then just post whatever payload to it. Now notice that while it can be triggered by the API gateway, it can't actually interact with any other resource. The reason I can't do it is because we haven't given that role the permission to interact with S3. So let's just do that, and then we'll be done. For that, we have to create a policy first. And you can see this is a fairly restrictive policy. The only thing that we're allowing in this policy is to put an object into S3. And what it takes in as one of its arguments is the bucket. So this is the bucket that we had created a little bit earlier. So let's just do that. OK, so we have the policy. We have a Lambda role. We haven't attached one to the other. We have to do that as well. So you can guess it's new, something, something, role, policy, attachment. And we fit in some argument. The argument is policy, ARN, and the role. OK, let's call this API Hangout post to S3 policy. And let's call this API Hangout post to S3 policy attachment. So this is the attachment. We're attaching the policy to the row. Let's new Pulumi up. There's a problem. Looking for the beginning of object, key, string. Policy contains an invalid JSON. What is going on here? Can somebody figure this out? Let's do this again. I have a feeling that it has something to do with, does anybody know? Did anybody see this? No. OK. Let's try now. Policy contains an invalid JSON. What do you do in this situation? What's that? Yeah, so this one is the string that gets applied as soon as you do bucket.arn. Does this look like a valid JSON? I'm in the right meetup to figure that out. Is this a valid JSON?
Can we leave it up there so we can look at it?
OK. This one tells us that it isn't a validation. What if we remove this? OK. It didn't like this very, you can't add comments to JSON. Good. Let's see if this was it. Yes.
Yeah.
OK. All right, cool. So let's go back to the Lambda and see whether It has the right role, that has the right policy to interact with Amazon S3, and it looks like it does. OK, cool. So unless we have some application error, this at least is infrastructure-wise able to take in some payload and feed that into S3. Moment of truth. Let's figure that out. OK. Postman. The name of our bucket was API Hangout Bucket Dev. Let's go in. We got nothing here so far. And what is the URL? It's this. And it's a post request. And what's the endpoint? Do you remember? We had created an endpoint when we created the API gateway. Posting to S3. Posting to S3. All right. Body, let's do meetup name, API Meetup. OK, let's see if this works. It's loading. The first time you run Lambda, it might take a second because it's still a cold container. It has to wait until it warms it up. But right now that it's warm, you could trigger this thousands of times concurrently. This is one of the benefits of this. This just scales horizontally as much as you wish. Let's see if it actually got logged into here. All right, it's here. No, here you go. API Meetup. That was 5 minutes? How long was that? Roughly. OK, do people know what AWS Lambda is? I realize I probably should have asked that question before we started.
I've heard of it.
OK. Yeah, I'm going to start over. So one of the benefits of running your code on the cloud is that you don't have to keep running a server for just to get some. Let's say we have a function that gets triggered once a month, for example. There's no reason to just deploy a server and pay for it to just continue to run all of the time. So instead, you could just take a block of code and then just put it somewhere in AWS and ask AWS to just provide you a URL, like we did just now with the API gateway. And then AWS basically gives you a URL that you can use to just trigger that function whenever you want to call it. And so you're not actually paying for any resources while it's just sitting there idly. The other thing is that you could just keep calling a bunch of these Lambdas and run them all concurrently. You could see here, if you go to Lambda, you scroll a little bit down. This is our S3 bucket, by the way. You see? Fed that in as the environmental variable. Use unreserved account concurrency. I can run this 6,000 times concurrently. It's going to be very difficult to scale out an EC2 instance that does that, for example, concurrently. And so you could even get that expanded if you just send them an email. I think by default it's like 2,000, and then I asked them to increase it, and they're like, fine. So this is now 6,000. That's what AWS Lambda does. Questions?
And we will save questions for
Ah.
the end after all the presentations.
OK.
Thank you.
Later.